Testing. Hello, class. Today we're going to be looking at section 9.4. It'll be assigned today, Wednesday, April 22. It's due next Monday, April 27. The main focus of this section is taking second-degree equations from word problems. Again, you remember second-degree equations are where the degree of the largest degree of any term is 2. And we'll be looking at problems, word problems that pertain to that. So we're going to start with this one. This one has to do with a work problem. And if you remember, our formula when we're working with a work problem is the rate of the worker multiplied times the time the worker is working gives us the amount of work done. It's very much like a distance formula, rate times time equals distance. This one is just rate times time equals work. Well, we also recognize that with that, we could solve for the rate by dividing both sides by time. So if I divide this equation on both sides by time, I would get work divided by time. And that, of course, is a ratio fraction. Well, in this case, let's set this up once. Walter can paint, one house by himself in 12 hours. So the rate of Walter would be one house in 12 hours. So I'm going to write that down here. Rate of Walter, rates of W, one house in 12 hours. So that would be 1 over 12. Helen can paint the house by herself in 16 hours. So Helen's rate, the work would be one house in 16 hours. So the rate of Helen would be 1 over 16. Hopefully you can see this main formula adjusted to work applied to our individuals. Now I want to know how long it would take to paint the house if they work together. Well, if they work together, we add these rates because they're putting them together. So our rate together is going to be these two put together, 1/12 plus 1/16. We need a common denominator, which would be 48. This gets multiplied by 4, so I take 1 times 4. This one gets multiplied by 3, so I take 1 times 3. And I end up with a 7/48. That's our rate together. That's going to be the rate we use in here. So my rate together is 7/48 multiplied times the time. That's what I'm looking for, how long it would take. And again, we're looking at one house. If it said 5 houses, I would have 5 here, but most of these will have just one house. So I have 1. I multiply by the reciprocal, and I get 48/7. And this, of course, would be hours. We could write that if we wanted to as 6 and 6/7 hours. You could change it to hours and minutes, but I would leave it in that form. Okay. This one is just kind of a review to get us back into the flow of work problems. This one really didn't do so much with the actual second degree, but I wanted to review these concepts right here once. Now let's take one where we would probably be looking at a second degree equation. Okay. If I do that, I should cover one more first. I apologize. Sorry for the delay. Let's take a look at this one once. This one has a little different twist to working together. We have our overall work formula, rate times time equals our work done. That's pretty much the same. I could solve this equation by dividing both sides by time. That would give me the rate again equal to the work divided by time. What's different about this one is I have one pipe that's filling the swimming pool and another pipe that is emptying the swimming pool. So to that end, my rate of the pipe filling it, I'm going to go R sub F, so that's the rate of the pipe that fills it. It's the work done divided by the time. Well, I'm filling one pool in 10 hours, so the work is 1, time is 10. The rate of the pipe filling is 1/10. The rate of the pipe emptying, it can empty the pool in 15 hours. So it empties the entire pool, so I've got one work done in 15, so that rate emptying is 1/15. Obviously, the filling rate is faster, more than the emptying rate. But now they say that they accidentally left both open. Well, that's kind of a rate together. It's a rate together, but they're working against each other. This one is adding to the pool. This one is subtracting from the pool. So I have the adding part, subtracting the emptying part, and I get a net rate of filling. But the emptying is being subtracting as the filling is occurring. Again, I need a common denominator. It would be 30. This would be 3 and 2, giving me 1/30. That's my rate together. So if they're working together, how long? So my rate together is 1/30. The time is what I'm looking for to fill the pool. Multiplying by the reciprocal, I would get 30 hours. Just a combined rate of working against one another. Take a look at this one next. One roofer can put a new roof on the house 3 times faster than another. Working together, now they're giving me the time together, but they did not give me the rates of each individual. So I'm going to have to define that again. Remember, the rate is the amount of work done divided by time. And my rate multiplied times time gives me the work done. Same formula we've been using. How long would it take the faster worker roofing alone? Well, I don't have each individual one. So I've got the slower worker and I've got one that's faster. So my rate of the slower, I'm going to call R sub S for slower. I don't know what that rate is, so I'm going to call it 1/X because it's looking at one roof. The rate of the faster, it says, is 3 times faster. So 3 times the slower rate gives me the faster rate, which is 3x. Now they're going to work together. So my rate together, this time I'm adding both. They're not working against each other. They're both helping one another. So that would be 1/X added to 3/X. That has a common denominator already. So I end up with 4/X for my rate together. So 4/X multiplied times the time. Working together, they have 5 days. to get one roof done. This would be 20 over x equal to 1. I can multiply both sides by my denominator. That allows me to cancel those. And I get x to be 20. In this case, days. That means that the slower roofer has a rate of 1/20th, 1 over x. X is 20. So I put the 20 in there for x. The faster roofer is 3 over x. That would be 3 over 20. They ask how long would it take the faster roofer, that's this one, working alone to get the roof done. So I'm going with this same formula. The rate of the faster worker right here is going to be 3/20. They're asking how long, so I'm looking for the time to get one roof done. I'd multiply both sides by the reciprocal, 20/3. These cancel, giving me time. And I would have 20/3 days, which would be 6 2/3 days. And that would be our answer for that one. Another example. This one is going to be a little bit more second degree connected. I'm looking at a rectangle. They tell me that the length is 3 more than the width. This is kind of an important concept. Notice the length is defined in terms of the width. In terms of the width, which I'm going to call W. So I'm going to let W equal the width of the rectangle. If the length is 3 more, that means I'm adding to it. So my length will be W plus 3. And I'll probably just put that in parentheses. They're talking about an area. The area of a rectangle is the length times the width is equal to our area. Well, my length is W plus 3. So I'm going to put that in there. My width we just list as W. They tell me the area is 40. As you can see now, we get that second degree equation, because when I multiply this, W times each part, I get W squared plus 3W. And I'm going to take the 40 and bring it across. It'll become a negative. And now I have my second degree equation. Pretty straightforward one. You could use quadratic formula. You could complete the square, but it's really easy to factor this one. W plus 8, W minus 5. That will give me a middle term of plus 3. That means this W plus 8 equals 0, which means W equals a negative 8, and W minus 5 equals 0, so W equals 5. Well, because these are dimensions, these are a width and a length, I really can't have a negative number to be a width or a length. So this is an extraneous root, doesn't apply to my word problem. The positive integer 5 is my width. So my W is 5. My width here is in inches. And W plus 3 would be 5 plus 3, or 8 inches. So my width turns out to be 5 inches. My length, 8 inches. But notice we had a second degree equation from that. I'll let you try this one on your own first, and then I'll follow you up. So go ahead and try this one on your own. If you want to keep working and pause it, that's fine, but I'm going to continue on here. What's a little bit different about this one is I have an original set of dimensions where the length is 8 more than the width. So here's my width, W, length 8 more. But then I have a new set of dimensions because each dimension got increased by 2. So that means this W got increased by 2. So W plus 2 equals my new width. Increased by 2, W plus 2. And my new length is also going to be increased by 2. So it was W plus 8 originally. Increased by 2 makes it W plus 10. So those are my new dimensions. And it says this new area will be increased by 60. Okay, well, what was the original area here? From these dimensions, my original area is going to be length times width. So that original area, A sub 0, will be this W times W plus 8. That original area will be W squared plus 8W. That's my original area. My new area, it says that if I increase it by each dimension by 2, the area, that's meaning the new area, is increased by 60. That means this will be 60 more. So this new area is going to be the same old area, W squared plus 8W, but I'm going to increase it by 60 or add 60 to it. That means now if I take the new width times the new length, I get the new area. Okay, so let's do that. The new width, W plus 2, times the new length, W plus 10, must equal the new area, which is W squared plus 8W plus 60. Multiplying or foiling this out, I get W squared, I get 2W and 10, which gives me 12W. And I get 2 times 10, which is 20, equal to W squared plus 8W plus 60. Second degree, but I got a W squared on each side. So really I could subtract W squared from each side. That gives me 12W plus 20 equals 8W plus 60. I'm going to take this 8W, bring it over, it'll become a negative. So 12 minus 8 leaves 4W. I'm going to take the 20, bring it over to this side, it'll be a negative 20, plus 60 is 40. Dividing by 4, I get 10 feet in this case. When they say find the dimensions of the room, they're looking at the dimensions of both the original and the new. W is 10. So my original width is going to be 10 feet. My original length is going to be this 10 plus 8, or 18. That's my original width and length. They said rooms here, meaning they must want the original room dimensions and the new ones. So the new ones, W again is 10. I have W plus 2, so that's 12 feet. 10 plus 10 would be 20 feet. So these would be the new dimensions. These were the original. A little more complicated because they changed those dimensions as we went through. Let's go to the next level again. This one's not as bad. I would like you to try it once on your own, and I'll follow you up here in just a moment. Hopefully pretty straightforward for you. We just used an area formula for a rectangle to find our length in terms of our width, and then plugged it through. We did have a second degree equation. We solved it again using factoring. By the way, if this equation right here was not factorable, you would go to your quadratic formula, probably would be the next best choice. This one's a little more challenging for us here today. I have a 8 by 12 picture. Eight by 12. I'm going to have a frame around this picture of uniform width, the same width. So in other words, I've got some type of picture frame around. But this picture frame is whatever the width is right here. It's the same width here. It's the same width here. Same width on the top. We don't know what that width is. That's what we're asked to find. What is the width of the frame? Let's call it X. So we're going to say let X equal the width of the frame. That means that there's an X distance here and an X distance there. I could go X right here and X right there. The distance down is X, the distance across is X, distance across is X, distance down is X. That means that the length of this picture frame, I've got an X here and an X here, so this length is 12 plus 2X. That's crucial that you see that. I got 1X right there, and I got 1X right there. So there's 2 X's on top of the 12. The width, it's 8 from here to here, but then I have 1 more X there, 1 more X there. So that is going to be 8 plus 2X. Okay. Well, the total area of the frame, total area, that would mean if the whole thing were one big rectangle, it's going to be length times width. Call that total area A. My length is 12 plus 2X right here. My width is 8 plus 2X. That total area, if you don't mind, I'm going to FOIL this out, put the X terms in order. So 2X times 2X is 4X squared. I get 16 and I get 24, so I get 32X. Double check that. 24 and I missed that. That's not correct. I get 16 and 24. I think that's 40. Excuse me. Didn't feel right. 40X. And finally, 12 times 8 is 96. That's the area of the whole frame. But they're telling me the area of the frame itself, that means just this band, is equal to the area of the picture. Well, the area of the picture, this is where it gets a little bit tricky. The area of just the picture is 8 times 12, or 96. So my total area, if it were solid, was all of this. I'll rewrite this a moment because I had it scribbled out. This is the area as if it were solid. But now if I want just the frame, so I'm going to put down here area of just the frame. That's going to be the total area, which is this. That would be solid, minus the picture part. So that would give me the total area minus the picture area. That's the area of the frame. Well, the total area is 4x squared plus 40x plus 96. The area of the picture was 96. That gives me the area of the frame. And they're telling me that area is equal to the area of the picture. So this is just the area of the frame. The area of the picture is 96, and it has to equal the area of the picture. These two 96s cancel. So I get 4x squared, 40x. Those cancel, but I bring the 96 over because I want it set equal to 0. Now, I can go to my quadratic formula, write the way it stands. I could complete the square the way it stands. I could try and factor it, but I can make life a lot easier on myself by recognizing all three of these numbers are divisible by 4. And I could divide 0 by 4. If I divide everything by 4, 4 divided by 4 is 1. 40 divided by 4 is 10. 96 divided by 4 is 24. 0 divided by 4 is 0. I just made my numbers a lot smaller. Again, I could use quadratic formula, but I also recognize that it's very easy to factor this one. I need an x plus and an x minus to get a negative 24. Two factors of 24 that have a difference of 10 would be 12 and 2. This factor will give me a negative 12. This factor would give me a positive 2. Because it's a distance, that's what x is, I cannot have a negative distance. So this is an extraneous root. So my width, in this case, of the frame is 2 inches. And that's what they asked for, the width of the frame. Kind of a tricky problem. That means it's 2 inches wide here, the frame, 2 inches wide, it's 2 inches wide all the way around. Okay. I'm going to leave rectangles now and look at numbers and their reciprocals. Just a little background, if I have a number 7, you know the reciprocal, this is a number, the reciprocal, 7 over 1, you reciprocate that, you get 1/7. So if the number is x, the reciprocal would be 1 over x. Okay? Because I'm looking for the number, that's what I'm going to define x to be. Let x equal my number. Then the reciprocal is 1 over that number. 1 over x. It says the sum of the number and its reciprocal. Here's the number, here's the reciprocal. Sum means I add them together. So x added to 1 over x, that's the sum of the two, is equals 37 over 6. Okay? Well, to simplify this, I have to get rid of these fractions so that I can solve them. What we're going to do is we multiply by the common denominator. 1, x, and 6, the common denominator is 6x. I'm going to multiply through by the common denominator. The reason I'm doing that is I want to get rid of these fractions. Nothing cancels here, so 6x times x is 6x squared. Here, notice the x's would cancel. So you'll be left with just 6 times 1. Here, notice the 6's would cancel. You'd be left with 37 times x. Now you can see it's a second-degree equation. I get everything over to one side. Bring the 37 across, it will be negative. Plus 6, get it all equal to 0. I can't divide everything by the same number because there's no number other than 1 that goes into all of them evenly. But I can try and either factor it, or I can try and use the quadratic formula. 37 definitely hints that it should be factorable. To get 37, I notice a 6 times 6 is 36. I'm within 1 here. So if I have a 6x and a 1x, to get a positive number, negative middle term, both signs have to be negative. If I put a 6 here and a 1 there, I get a negative 36 and a negative 1, which gives me the middle term. So that means x could be 1, 6. X could be 6 here. Well, either of them technically work because The reciprocal of 1/6 would be 6, and if you add these two together, you would get 37/6. The reciprocal of this would be 1/6, so really either one of these could stand for the number. It didn't say it had to be an integer. If it had said the sum of the integer and its reciprocal, then the number would have had to only been 6. The reciprocal would not have been an integer, but the original. But this one didn't say that. It just said a number. So I keep both of them. And our last problem here. 2 consecutive odd integers. Well, let's just take an example first. 2 consecutive odd integers could be like 7 and 9. They're both odd, they're both integers, and they follow each other, consecutive odds. We could say 13, 50. We could say 21, 23. A lot of possibilities here. Notice though that consecutive odds, this is crucial now, the second one is always 2 bigger than the first. Second one is 2 bigger than the first. So if the first one is x, like 7 could be x, the next one is 2 bigger, x plus 2. The first one is 21, the next one's 2 bigger. So I'm going to let this x equal my first odd integer. Then x plus 2 is going to be my second odd integer. By the way, if these were consecutive evens, it'd be the same thing. Consecutive evens could be like 8 and 10, could be 14 and 16. If x is the first even, x plus 2 is the second. So these could describe consecutive odds. These could describe consecutive evens, which is why I wrote them down here. Again, they say the sum of those. But we got one more term in here, the sum of the reciprocals. So the reciprocal of x is 1 over x. The reciprocal of x plus 2 is 1 over x plus 2. So these are the reciprocals of those odd integers. It says the sum of those reciprocals, the sum of these two. So here's my equation now. I got to add those two together. And what does that sum equal? The sum is 12 over 35. That's my equation. That's maybe the hardest part, is to get from all this information to this equation. I've got a lot of fractions. The way to get rid of all those fractions is to multiply by the common denominator. Multiply both sides. Well, the common denominator is 35 and an x plus 2. They're all separate. So you really got 35 times x plus 2. Both sides. 35 times x plus 2. Here the x's cancel. I'm not going to cross them out because I don't want to leave that x. I'm going to need it for the next term. But in your mind, you're canceling these two x's. You're left with 1 times 35 times x plus 2. 1 times 35 times x plus 2. That's 35 times x, 35 times 2 gives you 35x plus 70. That's when the x's cancel. This one, the x plus 2's cancel. This time I probably can cancel it out because I'm done with them. That leaves 1 times 35x. Here the 35's cancel. That leaves 12x times x, which would be 12x squared. 12x times 2 would be 24x. Notice by this multiplication by the common denominator, I have no more fractions. And I got it in my second degree equation. So let's get this equation set equal to 0. I got 12x squared. This 70x, when I bring that 70x across, I'm going to find it here a moment again. 70x across, this 70 will be a negative. Plus 24, I believe, gives me a negative 46, but you can check that. That's basically combining all the x terms. And I take the 70 and I bring it across. I finally have my second degree equation set equal to 0. Notice again, though, I could divide everything by 2 to make it a little bit easier. So 0 divided by 2 is 0. 12 divided by 2 is 6. 46 divided by 2 is a negative 23. 70 is divided by 2, and I get those numbers. Again, not super easy to see the factors here, but if not, you could use your quadratic formula. It is factorable, however. I'm going to have a 6x and an x, and I have to have, in this case, 5 and 7, I believe. That's because this 7x and 30x, they have a difference of 23. Want the 23 to be negative, so 6 times 5 has to be a negative. 7 times 1 has to be a positive. That'll be the factors. You can check it out. Again, those were a little bit more challenging, but if that's not something you prefer, you can go to that quadratic formula. Now, this 6x plus 7 equals 0. So bring the 7 across, divide by 6, you get a negative 7, 6. The x minus 5 has to be 0. Bring the 5 across and you get 5. Well, this time, notice they said they were integers. 7, 6 is not an integer. That's an extraneous root. 5 is an integer and it's odd. So then the next one, they want the, what are the original consecutive? It should just be numbers. I'm not sure why that off is in there. Should be integers. So my two integers would be 5 and 7. Write that a little bit clearer here. Those would be my original two. We already gave you the assignment for this one. If you remember, it was section 9.4. Sorry, here I got so many pages. It's assigned today, April 22, due next Monday, April 27. Have a good rest of your day.